blood pressure, and that is here, when we look at blood pressure and you were to take a blood pressure, remember you get two numbers, and we're going to do this in lab on Monday. Systolic blood pressure and diastolic blood pressure. And a systolic blood pressure is the pressure during ventricular systole, or as a result of ventricular systole, and the diastolic blood pressure is a result of ventricular diastole or during relaxation. And if we had a couple numbers, we could give, it's like 120 over 80. The units are millimeters of mercury or torr for that. Now, by the time actually you get to a capillary bed like here, you're far enough away from the heart that you no longer have this pulsing pressure as blood's being pushed out into the arteries at a relatively constant pressure. So when we talk about measuring blood pressure, my body's tissues here, they don't really care about whether the heart is in systole or diastole. What they rely on, what this blood pressure relies on here, is what is an average blood pressure in an artery at any given point in time. Right? Sometimes we know it'll be higher during systole, lower during diastole, but what we really want to know is we want to take a blood pressure like this and convert it down into a single number that's an average. So if you took an average of those two numbers, what would you get? So we're going to do something, we're going to call it the mean, which is an average, right? Arterial pressure. So this is the average pressure in the heart, whether you're in systole or diastole. So if you took a number like 120 over 80, systole, diastole, so 120 plus 80 equals 200 divided by 2, the average, right, gives you 100 millimeters mercury. That make sense? That's the average, right? Yes or no?
Yes.
Yes, thank you. That assumes this, though. That assumes that the heart spends the same amount of time in systole as it does in diastole. Contracting, relaxing, contracting, relaxing, contracting, relaxing. That it's in systole the same amount of time as it is in diastole. Is that true? No. So can this be right? No. That can't be the average. It has to be a weighted average. Right? What does the heart spend more time in? Systole or diastole? So there's two EKG tracings, right? When on this tracing are the ventricles contracted? From here to where? All the way over to here?
No.
What's this event? Repolarization and relaxation. So this is the duration of systole. Yeah? They contract. Ventricular depolarization and contraction. Ventricular repolarization and relaxation. We said that the other day. Ventricles contract, and then here ventricles relax. So that means all of this is diastole. Okay? So if we were to look at a cardiac cycle, it's actually about 1/3 systole, 2/3 diastole. So what's this number really closer to? Is it closer to 80 or is it closer to 120? It's closer to 80. So I need to modify this. So here's what I'm going to do. I'm going to now say the mean arterial pressure is your diastolic blood pressure. Now here it was diastolic plus half of systolic, right, to get that. Did I do that wrong? Oh, not half of that. Sorry. Diastolic plus not half of systolic, half of the pulse pressure, the difference between the two. That's how you calculate an average, right? This number plus half of the difference between the two of them would be that. What's the difference between these? 40. What's half of 40?
20, so 80 plus 20 is 100. That's how you do that out. But here I don't want to take half of it. I only want to take a third of it, right? Because I don't spend half the time contracted. I only spend a third of the time contracted. So it's 1/3 of. Did we talk about pulse pressure before in here? I can't really remember. You know, I did it last week, but I think I did it in a different class. So have we talked about it in here? No? Yeah, we did.